So, we will start orthographic projection sectioning in this chapter. Why sectioning should be done, outline, some conventions, definitely there are some conventions on line styles and few examples how to do sectioning. Let us start with this basic part of the sectioning, sectional view. What is a sectional view? First question you ask, what is a sectional view? A view of an object when it is sectioned or cut, any object when it is sectioned or cut by an imaginary plane to reveal interior details of the object. Once the object is cut, one portion is removed, usually the front one. The interior details on the other portions, usually the rear one, are shown in sectional view. Sectional view is usually parallel to one of the principal orthographic planes. Remember third one, sectional view is parallel to one of the principal orthographic planes, that means frontal plane, top plane or profile plane. So, basically sectional view, if I summarize with this, sectional view has been done to look at the interior parts of the object. Interior parts, what is inside? You can cut it any of the plane and take out the front part, then you can visualize and do the sectional drawing. Sectioning, let us start with simple example. A bridge is there, then a beam or rider is there with a roller as well as a support, roller support as well as a hinge support. Look at here, it has been constructed for road or maybe communications passing through one end to other end. If I take it cutting an object, this is your object, this beam, I want to cut this object at different sections. Outside it does not look good. If I cut it, look at here section 1 at this section 1 how it looks. The section 1 section is simple rectangle or square, section 1. Come to the section 2 at point 2, I can write it 1 at point 2, I got it, look at there. Section 2, look at this, how it looks section 2. Then go to the section 3, how the beam section changed from the both the ends, simple support or roller or hinge support from one end to other end, simple rectangular section or square section to it go to the I sections at section 3. Unless if you are not going to do or show the sectioning, the designer cannot understand what is there inside. This is the basic feature required as far as section is concerned. So, each if you feel, if you think in a beam there are different materials at different sections, then we will have to go for sectioning at different planes 1, 2, 3, I can do it 4 in this case, but in this case we have taken symmetry, because the sectioning 1, 2, 3, what is there, this material other side, if I take the symmetry other side it will be same at that interval. Then once sectioning is over, then cutting plane lines, cutting plane, a line on an adjacent view which shows the path of the plane that cuts the object. I am just reading it, you just looked at it. It is drawn as a thick line that has two short dashes next to long dashes and usually ends with two arrows that indicate the direction in which the sectioning is viewed. If there is an object, generally what we are going to do, it says two short dashes next to long dashes. This is long, one short, second short dash, then another long. It has its own meaning. If I show this, it means the object has been sectioned or cut in that line or in that plane. Once I show this arrow, this arrow means object has been cut or sectioned in this way. Forward, if I show this arrow in this way, object has been cut downward directions. Let me go to the next section, genesis. Some objects have different shapes on the exterior and in the interior. If you looked at here, there is a bottle and there is a cork. So, exterior this is a bottle or maybe bottle made of glass or maybe steel, this simple bottle, preserve your water or chemical. Then at the top there is a cork. That means two different objects. Here the object is different material wise, here object is different. Sectioning used to provide details of the interior, that is our first principle. We should cut it, we should know what is there exactly inside. If I cut it longitudinally, then I am able to know if there is a cork, how far it has gone inside, what is its depth inside this bottle. So, outside it does not reflect anything, but if I cut it at longitudinally, looked at there, the cork has been penetrated here or pushed inside up to this depth here. So, this is what you are going to show in sectional view. Second point is outside shapes do not reflect inside shapes. Looked at here outside how it looks, cylindrical shape, cap is there, at the top there is another cylindrical circular feature is there. Then if I cut it longitudinally, how it looks. Let us cut it longitudinally along the arrow, make the half, do the sectioning. Now, once do the sectioning, you can imagine this is not the thickness throughout, outside cap is not thickness throughout, there is a thickness, then there is a cover narrowed down, then it has been pushed inside. Again in this case there is a gap at the top. So, it is a airtight or maybe tightened from the top, it has been pushed. So, it reflects inside shape of the object. Sectional view, you should show the solids and voids. Simple pencil, if you take it, simple pencil, pencil is made of what? Simple example, say lead covered by wooden, lead covered by the wooden. So, wooden is a different material, lead is a different material. Lead has been covered by this wooden and there is a cap, back side sometimes pencil cap is there. There is a simple pencil, this is a wooden, and here I can see the lead, whether this lead is throughout or not I do not know, and there is a cap. If I cut it, then I can find it out, this lead is throughout and there is a wooden, then this is your cap. This is your basic. Sectional views typically pass through an axis of symmetry, as far as possible pass through an axis of symmetry parallel to one of the principal planes. I have said in the beginning parallel to one of the principal planes. This is in frontal plane. If I am looking from here, frontal plane, otherwise you can say x, y or z, then this is at your top front view, that means longitudinally you cut it, make it longitudinally two parts, first one, so that you can see it in front face what is inside. Then at the top you can cut it, you can cut it at the top or maybe at the middle, I can cut it at the middle. So, parallel to one of the principal planes. Basic items in drawing a sectional view, what does it mean? I cut it longitudinally, then want to show what is the basic material, how the material has been made. This material is throughout solid or hollow, or some part is hollow again throughout the solid. Unless if you are not cutting it and looking it inside, you cannot define it. Sectional view at AA. In this case what happened? Longitudinally it had been cut from the top view. This is your top view, longitudinally you cut it. Then what happened? Once you cut it, this part you have taken. If you looked at here, the arrow mark, again it has been shown, one dash, small dash, again small dash, other dash. This shows your sectioning, this line shows sectioning, arrow A at AA. That means this part after sectioning I will take it out. I cut it in longitudinally, then once the sectioning is done, I will take out where I am looking at. If I am looking at from this side, I will take out that part. So, because the arrow shown at AA and this is your sectional plane, so you cut it and take out the front face. Then you looked at, once you are going to look at, you are going to look this surface here, here, here and here, this part you have taken out. Then once you looked at how it looks, you are looking from this side front, then what will happen? This will all merge. This is what? This point to this point, this point to this point, this point merge, and there is a gap. This is your hollow sections. That means it is throughout because you cut it longitudinally. Then you can show that what is this material? This material is made up of wooden, steel, concrete. There are different construction shapes. You have to mark it so that very easily somebody can say, oh, this material, after looking at these arrows, this material is made up of this. Which piece is being viewed? That is again important. Looked at this, which piece is being viewed? I have explained last slide and how. Sectioning has been done longitudinally. Look at this, it has been cut it, then you take out. You take out this part, then looked at from this side, then how it looks. Types of sections, there are different norms. As I said, there are different principles, different norms how to do sectioning. Full section. In full section, a sectional view created by passing a single cutting plane. A sectional view created by passing a single cutting plane throughout or completely through a view. Any of the view, single cutting plane, entire view, or cutting plane passes entirely across the object, that is called your full section. Looked at here. In this case, cutting plane passes through the entire object. So, I can see what is inside this entire object. Half section, first one is your full section you can show, second one is your half section. A sectional view created by passing a single cutting plane only halfway through a view, or cutting plane is imagined to extend halfway across then forward. Used for symmetrical objects, particularly why half of the section, if you do one half whatever the material is there, second half or the other half same material will be there. If it is symmetry, not necessarily show the entire sectioning, rather you show half of the sectioning. Earlier I have shown full, in this way it is full, now I am making it half. Offset sections, full sectioning, half sectioning, then offset sections. What do you mean by offset sections? Look at the object A, B, just C, just visualize A, B and C. If you looked at the object A in this case the holes are equidistant and aligned in the same line or same plane, particularly case A. So, if I take a plane in such a way that it makes the object half and the plane passes through these holes at the middle, then I can see what is inside the hole. The hole is throughout or half of the hole or anything else. Case 2, if you come to the case 2, there is a hole here slightly towards me, another hole is there slightly towards the rear side, one is at the front side, other is at the rear side. Then offset sectioning is required. In this case, pass the plane first in the hole at the center of the hole, then take perpendicular to this, so that sectioning will continuing second part of the hole. How it looks the section B at point B, here, here, here. Then example 3 or object C, there is a hole at the rear end, there are two holes, rear end and front end, there is a hole which is not throughout, from the bottom it is up to here, but top you are not seeing. So, that is why this is a dotted line. So, you start a section plane like this, cut half mark, then again take it back and cut it. If you looked at here, I can see rear side as well as front hidden holes. This is called offset section, so that all the hidden part can be taken care, inside features can be taken care. Offset section, a full section where the cutting plane makes right angle bend through the part to show details at different depths, height level. Remember this one, to show details at different depth or height level, different depth or different height level. If I put it in these directions x, y, z, this is my width, this is height, this is depth. So, offset section advantage is you can show the parts different depth as well as different height levels. Looked at here, top view of the object, how the section plane of the section has been chosen. Top view means, this is your top view means depth and width, no height, depth and width. Cut it perpendicular, so all inside features we cut it and looked at it, how it looks. Rotated or removed sections, be careful, this has been used particularly mechanical or machines, rotated or removed sections. Take one example, I cut at the middle, I cut at any of the middle, how it looks, there is a square shape. there is a T shape both the ends, it looks like. Now, how you are going to provide it? This is your top view, then you mark the arrow where you are doing this section, this is your section, then mark the arrow. That means what does it mean? You will take it out and look at, then this is the front part, front view, then take it out, separate it out, both the part, at the middle you are seeing, at this section you are seeing both the sides, this is your view. Take part by part apart, then how it looks? It looks like this. Then at these sections, particularly at these sections, how the object looks? It has been rotated, not like animation I have shown, but rotated means you can see both front and as well as rear, whether it is same or something different. Front, rear, rotated sections. Then take the sectional view out, remove sections. Then this is your sectional view at AA, then draw it somewhere else. What does it mean? This is a rotated removed sections at AA showed separately. So, this is required particularly machines and mechanical engineerings, one by one part, flange, wave connected, and what is there inside. This is varying sections, varying I beams, varying I sections, varying T sections. This is almost aerospace, mechanical, civil engineering also. These rotated sections and removed sections are very much useful. Useful for showing cross section of parts while saving space, Type of sections, removed sections used for some purpose as rotated sections, but instead of being drawn on the view, they are removed to some adjacent place on the sheet. Looked at the removed section, that was your rotated section 1 1, let us say this point 1 1, let us say this side 2 2, how this section is varying. If I write it 1 2 3 3, then 4 5 6 7 8 9 10. An object, how this is varying inside 1 2 3 4 5 6 7 8 9 10, it is consistently or continuously it is varying from 1 to 10. So, I cut it and removed the section and showed it outside at 1 1, you can say at 1 1, at 2 2, at 3 3, at 4 4, at 5 5, at 6 6, at 7 7, at 8 8, at 9 9 and at 10 10. One more example, removed sections. Look at this object top and front view, and it has been made at AA, BB and CC. How AA section it looks like? At AA the sectioning has been drawn, taken, and sectional view has been drawn here. BB sectional view has been drawn. CC sectional view has been drawn. Looked at it, how it is varying from section AA, BB and CC. In CC, while reaching from AA to CC, this part is slowly vanished. Another one is your aligned sections. I am going one by one types of the section. First one is your full section, half section, then offset section, then rotated or removed section, then your aligned sections. A sectional view where the cutting plane changes directions or direction at an axis to pass through a feature which may not necessarily lie along a flat cutting plane through the body. Aligned sections, you see. What happened if you looked at here, if I am putting a sectional plane here, this part is lying in this body, but if you looked at here, if I am cutting, this part is missing, this part is missing. So, I take it and align where the other part is there. Another one is your assembly section. Assembly section basically this is primarily for automobiles, mechanicals, aerospace, of course civil engineering. So, assembly section means there are different types of objects and different materials. So, these materials has to be first assembled, circle, cube, different shapes assembles and prepare only one object. So, first you assemble it, then take the section wise, then show the sectional view. Looked at the example, made up of combination of parts, different parts. All the previously mentioned types of sections may be used. Most important part, there are 2 points, one is made of combination of parts, different parts. All the previously mentioned types of sections may be used, cutting plane may be used, that means full, half, offset, rotated, all the sections whatever has been discussed may be used. Looked at here, different parts, part 1, part 2, part 3, part 4, part 5. So, it can be connected, it can be joined first. So, this should look like one object, then you can go for section. So, how many types of the sectioning now? First one is your full section, second is your half section. Let me go through this. Then offsets, first one is your full, then half, then is your offset section, then rotated or removed sections, then rotated and removed, rotated is different, removed is different, then aligned sections, then assembly sections. Drawing practice for sectional views. The edge of the cutting plane is shown in an appropriate view by the cutting plane symbol with reference letters and arrows to show the direction in which the view is taken. I have shown in the beginning the direction, particularly if you are showing this section like this line shows that this is a section. Then if I am showing this arrow, that means this is my directions, particularly viewing. I am doing this sectioning and taken out this and viewing this object in these directions. How it looks? The edge of the cutting plane is shown in an appropriate view by the cutting plane symbol with reference letters and arrows to show the direction in which the view is taken. Same thing as I said, the nearer person is assumed to be removed to make the sectional view. If I am cutting this, the nearer person assumed to be removed. I am cutting this plane and this part has been removed. How it looks after removed? Then Same thing, the portion of the object assumed to be removed is not omitted in making the other views. It has been assumed it has been removed. In the drawing, not necessarily that you will remove and show it that it has been removed, then you have been viewed. This is an imagination. That means, the way the direction has been shown, in that direction you are viewing, and where you are viewing the nearer person in imagination has been removed. You see, object is there, I am showing a plane where this cutting plane is there, but that does not mean that I am showing and removing this again showing this sectional view. Same thing, unnecessary hidden details, hidden edges, surfaces are not shown unless they are needed to describe the object. Unless it is not necessary, it is not required to show the hidden objects or hidden surfaces. Looked at here, not necessarily show the hidden surfaces here, 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 if it is unless otherwise if it is not required. A and B, in A I am doing a sectioning here. So, what happened, this whole half, this is there, then circular inside hole, then these are aligning, hidden, by hidden I am showing it. It is required in this case, because how many number of holes are there, so that knot and bolt system can be made, but here it is not necessary, that is why it is not shown. Necessary hidden details, hidden edges and surfaces are shown if necessary for the description of the object, as I said now. Same thing, visible details shown in sectional view, visible details, if you are cutting it, looking at this, what are the things inside, it is visible, curved surface visible, here it is visible, this part is visible, this part is visible. Once it is visible, you have to show it. In this case, I have avoided these visible details, but here there are visible details. So, then this is not correct. I will stop it here. Next class I will start few examples, whatever the principles I have discussed, few examples of your sectional views. Thank you.